and professional in the field of mechanical engineering and manufacturing systems. Dr. Chandra has completed his B.Tech in mechanical engineering, M.Tech in machine design, and PhD in design of manufacturing systems from reputed institutions includes BITS Pilani and IIT. His major area of expertise is design and simulation of manufacturing systems. He has significant academic and industrial experience and has worked with organizations such as Century Textiles and BC Ball Bearings, Jaipur. He has also served in various academic and administrative positions and has worked with universities in India and abroad, including institutions in Saudi Arabia and Ethiopia. Dr. Chandra has contributed more than 26 research papers. Give a big hand. एक बार तालियां बजाइए आप सबके लिए. This was really a very big achievement. More than 26 research papers to national and international journals and has guided more than 40 MSc dissertations. His research work has also received recognition, including Best Case Study Award and Best Paper Awards. He is also an accomplished author. His book include Maintenance Engineering and Management and Implementation of Total Productive Maintenance in Ethiopian Industries. With his rich experience and teaching, research, industry, and academic administrations, Dr. Subhash Chandra brings valuable expertise to this conference. We warmly welcome Sir Dr. Subhash Chandra Sir and look forward to his valuable insight and expert guidance. So, most welcome, sir, from KIPM College of Engineering and Technology, GIDA Gorakhpur. We are all here to, and we are very enthusiastically waiting for your expert and friendly talk, sir. So, please, you can start, sir, please.
Thank you very much. And let me can you see now?
Yes, sir. You are audible, sir. And we are also seeing you.
Yeah, can you see the screen now?
Yes, sir.
Okay, thank you very much, Doctor. And let me begin. And I congratulate you, all the team, for hosting such an international conference on intelligent systems, sustainable manufacturing, and emerging technologies, very relevant for the nation and for the development. Now, my topic here is sustainable manufacturing, green energy technologies with a special emphasis on biomass and sesame briquette production. So, as the things will go, like we will have deliverables related to introduction, background, and statement problem, questions, objectives, and literature review. So, these are standard headings, so we will not waste much time. Then we have literature review, and we go to the next slide. I think if I make, is it okay now? Better?
Yes, sir.
Okay. So materials and method, and we will go for data analysis and then results and discussions. Some abbreviation may be new, like MOVE, Ministry of Water and Energy. Circular economy we may use like CE, IEA, International Energy Agency. SRETs are small renewable energy technologies. AR we will use for agro-industrial residue, crop waste, and gross calorific values, and SDG, Sustainable Development Goal. And syngas for synthesis gases and greenhouse gases, we all know. So let's begin from the basic, like what do we mean by green engineering, sustainable engineering, renewable energy, and other, so sometimes people are green engineering. When they say, it's very common, green means it is related to environment, and mostly it has come from the plants. So the forests and plants are very important and vital for ecosystem, for giving us oxygen, for controlling the environment by especially the absorbing the carbon dioxide emitted from so many like from vehicles, from households, from furnaces, from electricity generation, and so much of, I mean, burning this and like so much of everything that we use even in the stove, it emits the carbon dioxide. So green energy is mostly it focuses on our environment, and we should talk about pollution control mostly, and we should see that our environment is protected. So discussing like eco-friendly materials, and nowadays we all know we are working on biodegradable materials and such things. And also going for miniaturization, we should not waste too much of material that can be produced by small materials. So the if you see the weight of the aeroplane, the materials that are being produced, like the titanium alloys, which are very light but very strong. So these are the challenges that we should provide and produce and save our planet. When we see, actually, okay, I have here good the screen. I want to see. So let me something pointer. I think now pointer is also visible, not visible.
It's visible.
Okay. And when we say lot of people, you will find for sustainable development, sustainability, sustainable manufacturing. When we say sustainable, then the sustainability is bigger than green. The environment is one, efficiency is another one, and we should also see the economic viability. So this sustainable will include some extra things. That means it is bigger and larger picture that includes the other areas, and it says cradle to grave. Cradle means from where you start. Like if you are making a cement, that does not mean that cement is simply we have converted and disposal. If we start like plastic, we start from petroleum. I mean, first thing is exploration of oil, then filtering, then separating, then processing, then making granules, then again up to the grave till it goes to the graveyard. That means the final when you uh, dispose it off. So till then we should see that is the sustainable manufacturing. If it is biodegradable, it will be good. And we have to see the other areas. And renewable energy, we know that those energy which are very well known, that which are renewable in nature, like wind, solar, created, and they are naturally appears and available. Biomass, again, people talk about what is biomass, what are biogases and things. So we have lot of like crop based, and in India also we are agricultural economy, and we have many crop based which are left out, and finally because that awareness has to go, uh, because of these like leaving out sometime maize straws, sometime paddies and other things which decompose and then creates methane and other kind of gases. And agro industrial, like we process a lot of agricultural things, and then the byproducts are there, maybe coconut byproduct left out, maybe the maize cobs are left out. So these things could be in the category of biomasses. So here we will not go much about these things, but you will see some of the pictures. Like in the global, we are using 15% of the energy consumption using the biomass, and some country are using 90%, like even Thailand, Philippines, and more of African content, I mean continent. So we will see now the sustainable manufacturing, as we have already cleared out, that it will have three things: the environment, that is green part, and the other two parts are added like resource efficiency and then the economic viability. So the life cycle assessment we will see in detail. People work on life cycle assessment, and we will see some examples. You can see here, like especially uh, the CO2 that is coming and the nitrogen oxide from chemical and other things in gigatons of CO2, which is more than 50. From 1970, if we start something maybe little amount that was 30, and almost it is doubled in this. So if this thing continue, I think it will be very, very difficult. And you can see the yellow part like transport and industry, they are taking the major part, and then energy production and conversion, that is again the oil exploration, the all that we do it, it is a major, like very huge. So now anyway the people have understood, and the CO2 contribution is because of these areas, and that's why the alternative energy, like we use mostly nowadays solar, and we are also trying to use the electric vehicles. So these are the indicators. When we say resource efficiency, we can understand that the resources are like, we should always see any industry that is being set up today, they are not only focusing on the pollution, ISO 14000, 2000, and now they have to reduce, they have to reuse, they have to recycle. Such kind of things are focus for any new industry to be established. And we know that these biodegradable materials, recycling of the things, whether it is plastic or iron or other things, there is a supply chain, there is a refurbishment, and there is a, like, old equipments are taken away and then again they are refurbished to be used again. Now coming to this efficiency, we can achieve by optimization, we can achieve by new material, but innovation is very, very important. Like if you see, what do we mean by innovation? Innovation is something which is very different from what the past concept, past technology we use. Generally we use adaptive designs, whatever is there we put it something the similar type of fan in one way or other way. So we use for sometime for pumping, it is same mechanism. Sometime we use for air blowers, sometime we use, that is adaptive. But when we see, the one example I put for innovation is, you can see like initially in the beginning the photocopier, if anybody has seen, there used to be plate with carbon and a kind of fusing property, that is a plastic kind of mixture, and then that light used to fall, and then there was a kind of magnetic drum, and then the another light reflects, and then it will de-ionize the white part, and then that ink will be fused and transferred. So but from there we have gone to inkjet, that is innovation when it is then it has gone to laser, and now there are because of internet of things, they are working actually. So they are digital, that means it takes into digital forms, and there is all these things, and then printing part is done. So they scan and make that one. Team is sharing a window. Okay. Adaptive designs are common. We use augers for material handling, that is spiral kind of things. So that material handling to plowing to different digging holes and something, it is very convenient. So these can be exploiting one technology that is available. Now when we talk about economic viability, we have to think out of the box and in a big way. I mean, we should not do the same rhetoric things and them repeating the things which are done. If we think something innovative and making, so you can see here a graph, the time horizon. If you are simply optimizing some parameters, current, this, voltage, this, you may get something, quality of welding or machining, depth of cut, this surface roughness may be there. But you have to go something beyond, that is systems design. And if you want the larger achievement, then you must think of innovation. So it is very clear that innovations are the way, and that's why there are innovation centers created. there are incubation centers created, and now we are also doing in India the startups, and you have to think of making something. We are relying on something. If the house is made of bricks, we don't see like, okay, it is available, it is this one, and adaptability is not there. People are very hesitant. So we have to, make our thinking different, and we should adopt innovative approach. Now, if I show you here something, uh, here you can see this is the R&D expenditure. Of course, it is for 2016 data. You can see here China R&D. It is percentage of GDP. Now the GDP of China is almost like more than 5 times, 6 times roughly. And then also if you see the graph, GDP it is 1.6% at that time. Now they have crossed almost I think 3%. And if you see our India is below 0.8%. So I think the focus, and nowadays a lot of discussions is going on we know it, the budget on the education people are saying, and you are all aware, yes or no? Hello?
Yes, sir.
Are you hearing me?
Yes, sir. You are audible.
So we know the budget like 2014 it was 80,000 crores. Now it is increased to 140,000 crore. But if we convert in the GDP, it is not significant. And dollar and this one, it is I think really alarming, and people have to be aware that saying something percentage, but we have uh, opened so many universities and so many uh, and now the share becomes very small. So I think these are some of the things. Now you can see these other countries like Brazil. You can see Brazil is much above than India. And if you see some country MBIS is a Malaysia, and you can see their GDP is very small. So but still they are sharing, and no problem for them. And if you see country like Turkey, if you see here Turkey, their this one is still so, and it is clear like they are really doing relatively well. So we have to focus on that. Now because of we are talking about green, we want to say planet and sustainable. So here the researches are going on like because of the too much of CO2 emissions from different sources, they want to pressurize with a very high pumps, and when it is at high pressure it can become liquid, and they want to put in the earth core inside where these stones are there, and this will slowly go and then get converted into oxygen will be released, and then carbon will be again left, so that this can be again as a fossil fuel. So these things are already being in the research areas in the developed countries. Miniaturization, I have already talked that we should go for making smaller items, smaller things. We should not make too much big, and you know that like everything is becoming, even on a sim, we are going from normal to micro to now nano, and then no need. It can be removed. Similarly, there are many things. If we see the engines earlier and now, we don't want to unnecessarily waste too much of material. So these are miniaturization approaches. And now we go fast to these, some of the related to mechanical engineering, and related to some different areas like how we do these. We talk about green manufacturing, so these could be some examples like near net shape forming and near net shape powder metallurgy. So now we are not converting like solid and by forging or by melting and giving the shape through casting. We are trying to give even by forming, so that by powder metallurgy the shape is near net shape, very small amount of machining is required. So this kind of approaches are there. Similarly, when we are doing forging and something, if it is cold, it needs lot of high amount of force and energy. So we must go for warming them and then doing it without altering their microstructural properties or their the strength or other like fatigue strength, their compressive strength and other. High efficiency hot forming, we should not use this old type of like burning too much of coal, so which is polluting environment. And you can find on these like what we call typically the blacksmith people nowadays. There are on the roadside you get whatever you need. You want to get shovel, you want to get fork, you want to get knife, you want to get something, they are doing it, but it's emitting lot of carbon dioxide. So we should use induction furnace, resistance furnace, infrared, so that rapid heating and energy saving can be done. So these are some initiatives worldwide people are taking. And you know the technology is changing. The same conventional old furnaces are not. We should also talk about the lubricants, or there should not be any lubricant. So these kind of approaches are being discussed. Like we should use vegetable oils, synthetic, I mean biodegradable lubricants, and some kind of nano lubricant, so they can reduce the pollution. We should also use the tools with the, you can see like advanced coating. So these are like physical vapor deposition, chemical vapor deposition. So advanced technology we should also, if we don't produce, we should import, we should work on that, so that the tool life is increased and we need not to waste again grinding, redressing, regrinding and doing like that. So there are a lot of other like ultrasonic horn which are vibrating and trying to reduce and get good finish. So such kind of people are working in those grinding bill, ultrasonic horn, and publishing the paper and seeing the surface roughness, finish quality, and the cost of that. So this we can really reduce. Next one we see like incremental sheet forming. There are techniques for ISF. Superplastic forming, nowadays all these turbine jet engines, they are using very promising, which can sustain 2000 degrees centigrade temperature and very lightweight, and it has a very high strength in terms of uh, yield strength, fatigue and failure strength. So they are using superplastic forming at high temperature, low strain rate, and so that it can be very light weight. Like especially now the time is for the jet engines and supersonic fighter jets. So the material is one of the challenges to design the blades, and these blades are under very advanced technologies. Now we see some of them, like already these energy consumption we have to minimize. So how we have to think in that way. There are techniques like very high speed which can run not like 1000 or 5000 rpm. Machines are running beyond 50,000 rpm, 170,000 rpm. Now these rpm cannot be made possible using our traditional bearing. So we use these levitated magnetic bearing, and they are called high speed machining, HSM. And almost at that high speed, the temperature is not transferred to the tool, and rather it is being taken away with the chip, and we don't need even lubricant. So such kind of new technology we have to use. So here are some, like especially with the lubricant, we should use highly pressurized with some additives. Research has to be done to improve the lubricity, reduce the friction, and they are pressurized and then in the form of a spray. So this can, a small amount of lubricant can take much higher heat. So these are the areas where people are trying to work, and technology which are being taken place for sustainable. And already we talk about these air emissions that we have to minimize. And the other one is water consumption. Water footprint is another very challenging area for sustainability. So we have to reuse, recycle. As you know, everything that any factory, whether it is tannery or any chemical, people are very much the educated fools. They say they are educated, but they will, if you see batteries, assets, cleaning acid in electroplating and other industries, there is no civic sense, and no those municipality corporations are taking seriousness, and those waters are flowing. If you see our drainage systems across the city, and they are polluting the water, and lot of diseases are appearing, lot of problems are coming because there is no prevention for that. So it is really very, very worrisome. Now I tell you just why water is important. You can see, like, water is free and something, and people are just spoiling it. Even from houses, they are just, washing. They are doing something in place of one bucket, five buckets, open shower, and they are simply keeping open the water lines and sitting. That's very bad. You can see, the if you are drinking one cup of coffee, it is not reached to one cup. It has already used 132 liters of water. And if you are seeing the other one, the wheat, that is wheat, we know that 1 kg of wheat has used 3300 liters of water. We use flooded irrigation. And same like for rice. And if you are thinking of cotton, if you see, we get cotton, we get cloth, we throw it, we do something and don't maintain it. It has consumed 2700. So it is very, very. And those who are non-vegetarian, chicken has consumed till it reaches to your this one, after washing, cleaning, 3900 of liter. So these are all the issues that the water life cycle assessment is also important. So we should not simply see on the top, because some of the things we have not valued. We say it is all naturally available, so there is no cost, but it is costing. So here life cycle assessment is very important. That is already we discussed, from extraction, processing, manufacturing, handling, transportation, use, and disposal is very, very important whenever we want to do something. That's why it is called cradle to grave. So now a lot of researches are being done in the life cycle assessment of something, that product is being made. And you can see here, sometime when we see life cycle, you see here we have used like plastic bag or paper bag. But when we see the raw materials, of course, it is natural crude oil. Paper bag is wood. When we say energy use, wood, we use more energy. But mass of the solid waste in grams, it is for one paper 50 grams. Plastic is only 1/4 gram. Mass of CO2 produced. CO2 produced when we produce one paper bag is 0.53. Plastic bag is 0.23. And volume of fresh water, if we see, then we are using this one. So you can see 4520 fresh water. This is 255 in cooling, some other application. So here it seems like CO2 produce is less. Life cycle assessment, not by biodegradability. So biodegradability is another issue, and you can now see that it looks like paper bag is, seems life cycle wise, is very, very challenging compared to plastic bag. But anyway, the disposal has to be looked after. That is one parameter which is very bad. Now we go to the simulations, because all the students are engineering students, and whenever we do make any product, we design any product, we should not go and okay, cut and weld and do it. It is not possible actually. That is just copying something, YouTube learning, and you don't know the material property inside what it is. So we have to know about microstructural, about their uh, other alloys, other components that are there. Steel are many types: mild steel, medium carbon, high carbon, stainless steel, 310, 410, and others. So there are components and the properties will be changed, and then the price is also different. So you have to decide which is which is optimal for your cost and with mass and design. So it has to be advanced in that. And you can see here simulation can provide without having the real producing by die punch, and then you find somewhere failures, and you cannot waste lot of time and energy, and that makes the little knowledge is very dangerous. So you have to be very thorough, otherwise there is a risk. Same like you can save your cost using some simulation. Here I am just showing for those who are mechanical, they are using ultimate tensile testing, and we can find what is happening and how much elongation and what will be the ultimate tensile strength, yield strength, and plastic deformation can be easily found by simulation. Here you can see even for machining we can do the same. So we should find out first what is happening, what will happen to the tool, what is the tool material, will it withstand, or it will be coming to this artificial intelligence, internet of things, and machine learning. Now I think for all the engineers, what I feel, whether they are civil, mechanical, electrical, electronics, computer, whatever it is, like in our olden days we used to learn, I don't know how many people know, it was quick basic, then came Fortran, formula translation, then came Pascal, then came C, then it becomes C++. And after that, it has changed to so many languages, Java, Python, and I think now the Python is one of the main area where you are going to explore and find lot of things. So my personal appeal is that anyone from any area, it is not like only for computer science, must know Python, must go, because there is learning thanks to YouTube, that you can use Jupyter Notes, you can use Anaconda, and you should know all the library, and it's very much handy that you should learn for solving your problems, and you can get by Chat GPT and others, and they are helping you. So it should not be like it's a freely, so leave it, I mean we can do anytime, but it is very important. So please all of you do these things, go and learn the library, NumPy, math, and others, uh, matplotlib or other issues. So here why it is important is because we use computer vision, we use internet of things, we use a lot of sensors which are very effective to give early warning, early detection for any problem. So I think that we have to equip. I think we are lagging in our teaching, learning, pedagogy, our experimentation. I think theoretical learning, getting grades, passing, getting degree is, I think, is the minimum requirement to really be effective and innovative and to be creative person. And the, like India is highly populated, and too much of competition, and lot of reforms are needed, I think. So some of the areas we are just trying to buy sensors, use them, or bring the machines. You can see now all these type of sensors, different type of sensors, like some are sound label, they are sound, and then they are detecting if anything is there, if there is some kind of sound is coming, abnormal sound is coming. There are acoustics emission sensors which can sense even if there is a something, if you bend the wire and you put the acoustic sensor, it will give some sounds. So the materials itself is going to produce in the microstructure. That means when atoms or the lattice or their crystal is grains are touched and moved, and if there is a abnormal, then you can. And there are a lot of other things like ED currents and other sensors to detect all this thing. And lot of people, they are aware about the load cells to measure the forces, to measure the torques, and the strain gauges are used in that. So we have to look for and creating something which can be related to our this one. Now I am coming to this because it's another area is bioenergy, and you can see here the percentage share from coal 13 and 40% is oil, as you can believe that oil may be maximum, petrol and diesel and other things. Bioenergy is having 11%, and then we have 19% electricity. So this is the worldwide, but when we see our energy consumption, it is also understood. This figure is just to know. I mean, we should also know what we are. I mean, knowing ourselves is the first step to either progress or not. Can you see here this graph? Yeah, liter of oil per day. Now it is something like 0 and then 0.5, then 1, 2, 3, 4, 5, 6, 7, 8 up to this side is scale is high because otherwise it will become too long. So here you can say 5, then 10, 20, 30, 40, 50. Now you see here, can you see this one, India? Yes. So if you see their consumption per day, you can see per capita because per capita is very important. That's so. So here is a Pakistan, of course, and there is a Nigeria is more, okay, but they have other issues. India is here, okay, and you can see here Costa Rica, Brazil, Mexico, China is Russia, Israel, Japan, Sweden, Canada, US. So this one is our, this directly reflect that the kind of per capita may be low. Uh, so I mean it reflects a kind of our economic condition at individual level. And now we come to this some of the renewable energy data. Actually, we because it was with the special reference to a case country. The case country has something like there is for our, if you are aware that we have India is the main this one for International Solar Alliance, but the America has already gone out of that. It has withdrawn its fund after Mr. Trump become president, and so there is a solar energy is very limited application here because it has very good sunshine. So the if there are some people from electric field, they can I think talk about it. And from electrical engineering, you have one of our very good colleague, Dr. Ajay. So you can also discuss, I mean, what it is. Geothermal is 10,000 megawatt, but it is only 70 megawatt is used actually. And there are other geothermal America is working and those are working. So wind power is also very high here, but less exploited. And here the problem is, you can see here when you see the bioenergy, bioenergy is almost invariably you can see there are forests, so but forests can be used for these like um, uh, carbon credits are given nowadays, but they are using for, you see here, bioenergy for burning, cooking, coffee, everything. I mean their cultural way, so they are using that one. And here, of course, for India, we have tried to do, but I know the village and other label again cylinder and something people are going back, but they have to use something like these kind of rocket fired chulas stove if they are anyway using the wood or wooden type of stock from agriculture or something. Now here the you can see again firewood, fire purchase, fire charcoal. So all this blue, it is almost like 90% is used by them. So there is a great challenge in African countries. You can see very limited amount, 1%, 2% is electricity used for especially the house application. The remaining is mainly cooking because the temperature here is around the year is less than 20 or around 20. So they don't need fan or air conditioned in car as well as in houses, but only the cooking and slow cooking like the traditional in India sometime they used to do. So anyway, these are energy figure and facts, and we have seen the biomass in earlier other figures also. Now here we try to see that if we have data, we can convert it. So there are many in India also nowadays, if you are aware of it, there are bamboo, which I think if you will Google it, we are getting even for our incense stick, agarbatti, we are getting the bamboo, this one, which are in tons from China. And China, for your surprise, many of you must have heard the, I mean, the Amazon, China Amazon. Like America, there is a Amazon, that is a forest. China has created bamboo forest, and it is used for so many applications. And there are bamboo varieties which have high carbon contents. Better we also go and focus on that. We have lot of this jalkumbi, hyacinth, napier grass, jatropha, and other prosopis juliflora, and we can use all of them. And now India is also taking initiative that all these thermal power plants should have 5% biomass. Even the coal one should have, and oil fired should also have 5% to 10%. So here we have to see these kind of the questions were many, like deforestation and soil erosion, because we are cutting plants, and the the oxygen deficiency is happening. Carbon dioxide is not being absorbed because there is no plant, and the carbon dioxide becomes a problem if it is more. So everything is at the optimal level is good, and there are a lot of health hazards. People are respiratory problems and other exposure, and especially the women's and children's, and that is why so this approach was there. I think that uh, that is that giving the gas cylinder, gas supply to all the areas. So this was one of those areas. But how many sustainability again becomes a question. If you do something, are you sustaining? If you are not sustaining, it is equally dangerous. You start anything, and you again suffer. So this Ujjwala scheme has come now. How much it is? So we have to see uh, the status. I mean, it's not one time. Plants are planted every year. 1 billion plants are planted. Second year, 1 billion planted. 5 year, you find 5 billion. If you go there, you don't find even 500 plants surviving. So that is one of the very important that we should see post. Like as product, we have after sales service. So we should see after some time what has happened after 2 years, 1 year, where it is gone. So the problem, good, I mean, drive of Swachh Bharat Abhiyan, Ujjwala scheme for sustainable development. Otherwise, people were suffering because of open defecation, like diarrhea, pathogens, and lot of other diseases, pneumonia, malaria, and other issues were there. So anyway, it is very important, but we have to find the ways and to convert them into the clean energy or green energy, we call them. So and we should also make adaptability. Now like solar panels are there, there is issue with the adaptability. It's not like a new technology, and it is not matured like electric vehicles. But still we are, if we make more and more solar, this one, I think hopefully we should be more self reliant, because higher production, higher things, it will make upward spiral. Like if you are doing good economy scale, lower price, and then people more buyer. If you have low volume, higher price, less demand, and then the price is high. So we have to see that policies and other things. So now our objectives are now here, because with the specific reference to biomass, we try to get the data and other issues. Significance is we can save our planet, because we know that greenhouse. Many people understand that greenhouse effect, it should be greenhouse. It is good because it says greenhouse. So greenhouse is good because we need these green gases, greenhouse gases. If we don't have these methane, if we don't have carbon dioxide, nitrogen oxide, if our environment is open, then the daytime we get too much of sunshine, and when it is sun is not there, we may get completely frozen because all heat will be uh, going back. So the greenhouse is good, but certain level. But if it is too much, the heat uh, from the soil, it cannot go back, and then we feel like what is happening in India. In the nights, we are still having lot of heat because temperature is rising, and summer is very much uh, unhealthy. So such kind of things we have to see, that is we have to find out. So here we have some data anyway, that literature review I collected through internet and some of the people for agriculture crop residue for major areas. And there are biomasses that were given in different areas wherever there are agricultural kind of things. So we have to use improved cook stove, we have to say small scale renewable energy technologies that must be developed in not only in stove but in other areas. And here we use the biomass conversion. The one is thermochemical, that is we call it carbonization or we call pyrolysis. So that must be used. uh, uh, so I think I have another 5 minutes, yeah, or you will give me 10 minutes. Hello.
Yes, sir.
Hello. Will you give how much time is left? 10 minutes?
Approx 5 minutes more, sir.
But you have pushed me 2, 3 times. You rescheduled. So you should consider me also.
Okay, sir. Uh,
Anyway, the pyrolysis is basically the, as we have seen that the synthesis gases, and so we have to take out all of them, because now we understood that plants absorb carbon dioxide, and that carbon dioxide we have to convert into the carbon, and oxygen will be, I mean, so how we convert that one, it is called the pyrolysis or we call carbonization. So we have to heat it, and there are temperature zones. Like when we say first stage, when we heat, we should see the moisture content is 10 12 to 15%, and when it is heated something up to 200, the water will be vaporized, and still the wood or the biomass is intact. Then we go for peak pre-carbonization, then up to 300 centigrade you get something like liquid and tar and some acetic acid type of thing and methanol. So these things we should have system with temperature control, and these byproducts are coming. And when we put above the 300 degree centigrade, our carbonization take place, and we will find that the fixed carbon content will be left. So that is called charcoal. So finally, I mean, scientifically, if we do, we take out carbon dioxide there, some part of that is coming, because when you cannot, the tar is coming, and there are the water which is called the wood vinegar. So all byproducts are very I mean, they are biodegradable and they are environment friendly, and we get from different species of wood or type of wood, we get something 50 to 70% of the carbon, fixed carbon, that can be used. Even that can be supplied to NTPC, and that is mandatory. Now people are using from even the I don't know, the straw used from um, uh, what we call this oh, sometime, uh, we use mustard. So mustard is there, tuar, and so many, I mean, these pulses, we use that, and then we compress. I mean, after we get this one, we get these kind of briquettes done. Here we found that some people who use You can see very traditional kind of things. Drum is there, and there is a firing from bottom, and then keeping controlling. Sometimes there you can see here there is a internal firing, and then there is no temperature control, there is no proper control time. Sometime more is burned, and then the temperature is there, so it is sufficient to create the charcoal. But if by chance you open it when there is a sufficient heat, it will catch fire. So it takes time. Actually, they are not efficient method. So because of that, and the like in India, the NTPC needs less than 5% ash. So that should be controlled. Like if you are doing something without control, then it's a problem. You have wood, vinegar, methane, CO2 is used for even extinguisher, firefighting equipments, and these are uh, fitted with carbon dioxide, and this is heavy. So whenever these extinguishers are fired, the oxygen is replaced and CO2 remain there, and the fire can be stopped. So traditionally, if you see some places, people are using these kind of charcoal production. Traditional, they make some kind of houses, fill it. It's like those who do our pottery people while they are baking their these matkas and other items. So it is similar to that, and it is non-professional. But here we need like pyrolysis must be proper. I mean the temperature, and then collecting CO2 is very useful for extinguisher. We have methane, we have wood, so that can be filtered in the layer by layer because it will be condensed here. And you can see here that we should use a kind of hammer which is more efficient for sustainability. And now the advanced countries, even they are using the fecal or the sludge from the toilet. They take the toilet sludge, and once they take it, they convert into the biochar or the carbon, and it is one of the very very good promising. And it is fast because they are cooling by water, so more industrialized approach. So immediately your input is coming and output is after cooling. It does not catch fire, it does not. So this, but this one has to stay for 5 hours, 6 hours, till it is cooling down. If you open by chance, it will catch fire. So such things are there. So here I have collected how many tons of yield is there for maize straw, for sesame stalk, for Haitian, for bamboo. So some 3 million, rice husk this much million. If we calculate the average calorific value, I just see the average because sometimes the mistakes are there. So this to this range. So if we take average also, you can see here like these from bamboo. These are kind of bamboos people are having in many places. Okay, so it is not that these bamboos are not being used. There are a lot of dendrocalamus, there are bambusa, there are this todla and others. And by the way, I tell for your kind information, the dietary silica is very high in bamboo. So if we use these leaves for tea also, then it will make our this help in absorbing calcium and making. So we should also use. That's why bamboo used to be like good. So sometime we have forgotten some knowledge which was there. Water hyacinth, this is very 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 terrible for ecology. It spoils the uh, complete the water system, and because the sunshine doesn't reach the bottom, all your other types of microorganisms will be dead, and even the fish and other things will die out because there is no oxygen mixing. And so it has to be, but it is very very good for conversion to biomass, and it is very good. So there are a lot of datas and things, so this I will skip them. Acacia and others. And when we converted those acacia rice which were common, not touching the forest, these are only which are renewable. And we try to conduct this kind of because it is a small budget. So you can see here we have used drum and we have self firing, and some timing and something we get it. And you can see here these type of briquettes were finally converted. You see here, these were done by the sesame. Sesame is that till. So from the sesame we have used baling, carbonizing, and all that. So you can, we have calculated how much energy we can, because such kind of drum type is very low cost. So we can use, and this was in joule this much, 12932447069. And when we convert into this energy, it was something around in the penta 1293, so 1293 point something pentajoule. We have taken other authors which was saying something in a range, but I just see that it is for with this one it is this much. And this can, if we convert into like how much tons of wood equivalent to how many tons of wood that we could have used, so we can convert and say that, and how many hectares of land it could have been like equivalent to that. All that can be interpreted later. Now here what we did for binder, we need some amount of, so we first we created this kind of, there is a ash and some percentage, and we get this much of biochar with different timing, because but 4.2 minutes was okay, but that was sufficient for this kind of that condition. Be mixed with the cow dung, and when we mix with like 20% binder as cow dung, we get 4540. And when we did with molasses, we get for 15% of molasses, the calorific value was very high, which we tested. And we clay is 4540. So here we find that this one is, you can see here the binder molasses gives the highest. That means we should use binder. Then we thought maybe there is a synergic effect if we combine three of them. Then we use some percentage of like 5% of clay, 5% of molasses, 6% or something of cow dung, and different experiment. But we didn't find that much promising. That means the combination was not promising, rather it is reducing. We don't know, I mean, the reason. And you can see here these brockets and these people working, and this is very nice. It has long shelf life, and it is very handy. It is smokeless, and these things can be used for cooking, even compared to our cow dung, because it has very high calorific value, almost equivalent to the natural wood. More than that, tests were done using these oxygen bomb calorimeter. We have heated and then checked the calorific value. And so results and discussion, anyway you have seen this country with the small amount of this, which is equivalent to, you can see here how many megawatt hour. So this is in, I think, 246 359 million megawatt hours. This much of electricity, this much of energy can be produced, and this is equivalent to this much 176 million ton of wood if we use wood. And if we say this wood from where it will come, like one hectare will have 100 tons of wood. 1 hectare will have 100 tons of that. So if we see this, you can see that this one is 14,143.5. Just yeah, 1 minute. Yes, yes, yes. Finished. The results and discussion. Okay. Yeah, finished. So anyway, these green energy, now I think most of the things are there. So already the results are there. We have also done regression to find out if there is anything better than that. So there is because the combination doesn't go beyond that. So you can see that this was the 20 or 30 years before the Tanzania and other in the we call it the Sahara suburban region. 20 years before it was like this left side, and now it is like this. And you can see this. So take away, you can take adoption and other issues, and the references no need to see. And then I think if you have any, this one is better late than never. So there are project that are done, Kisikai in Tanzania, and now they have this kind of, this kind of shoots from the plants have come. Thank you very much. There are Ecosia and lead organization, but you can see the left side, the barren lands, and now it is like this. Thank you very much.
Thank you, sir. Thank you very much. Dear students, respected Professor Subhash Chandra, sir, Federal TVT Institute, Addis Ababa, Ethiopia, sir. It is my great pleasure and privilege to express my sincere gratitude to you, sir, for delivering such an insightful and inspiring keynote address on the very important topics. Sir, your valuable insight, expertise, and practical perspective have greatly enriched our understanding of the importance of renewable energy and its role in building sustainable and greener future. On behalf of the organizing committee and all the participants, I extend our heartfelt thanks to you for taking the time to be with us and sharing your knowledge and experience. Thank you, Professor Subhash Chandra, for your inspiring presence and for making this conference more meaningful and more memorable. Thank you, sir. Thank you very much.
Thank you
Hope
very
so we
much,
will again
Ajit ji. Thank
in
you very
coming
much.
future. And sir, we are
So,
yes, sir.
yes. Tell me.
In future, sir, in next coming conference, we will definitely connect with you again, sir. And we are really very thankful to you. And our students are so beneficial, whatever you have delivered here. And it's time for the lunch, and the students are waiting. That's why we have completed it.
Yeah. For me also, I will go after some time, but good luck for the future endeavors. And I am very delighted, and really, this is very. I'm very happy. I mean, my special thanks are to you, to your organizing committee, and in particular to Ajit ji, to you. I'm really pleased that you have organized in a very nice way. So I hope
Thank you.
I see
Thank you.
the good future, good things in future for India
Thank you.
and especially for KIPM. Thank you very much.
Have a good day,
Okay.
sir.
God bless you. Okay. Thank you.